In this video, I'm going to show you how to solve a trigonometric equation. That's an equation that involves any number of trigonometric functions like sine, cos, or tan. And I'm going to start with a couple of easy examples to get you used to the techniques and the methods, and then I'm going to move on to a couple of harder examples in the next video. So to start with, I've got sine theta. I want to solve that being equal to minus a half. And for every trigonometric equation you're going to get, you're also going to get an interval in which to solve for your value of theta, which is your angle. Otherwise, you're going to get an infinite number of solutions. So the method I'm going to suggest to do for this is to plot the graph of the trig function that you've got, in this case sine of theta, and you want to be making sure that you're only allowing solutions in the appropriate interval. However, I've got the graph of minus 360 to 360 if I need it. So there's my function sketched. Hopefully you can do this from memory. And how are we going to get our value of theta? Well, if I want to get theta out of sine theta, the best thing to do is apply the inverse sine function. So if I do that to both sides, then inverse sine of minus a half, you can use your calculator. And that's going to give me minus 30 degrees, which is my first potential solution. However, minus 30 isn't in my range of valid theta. So what I'm going to do, I'm going to leave it on the picture for now and see if I can work my way into the right region of the graph, which is 0 to 360. So there's minus 30. I'm going to figure out roughly where that goes on the graph. That gives me a value down here, which will be negative. And to help you out at this stage, I'm going to put a horizontal line on that tells me where the other corresponding angles on my picture are going to be. So there's minus 30. It looks as if over here, these are the two angles that I need, which are my valid solutions. So how am I going to get those angles as well? Well, there's minus 30. We know that sine graph has got a period of 360. So if I add 360, that's going to get me over to this angle here. Adding 360 makes me up to 330 degrees, which is 30 away from the root over here, 360. If I reflect across the line of symmetry over here, then my other solution, which is also valid in this range, is going to be 210 degrees. Okay, so taking my principal value from the calculator, I can work my way across to the valid region of the graph, and those are my two solutions. So theta equals 210 degrees or 330 degrees. And that one's done. Okay, for the second graph, the second equation rather, it's slightly different and it's a bit annoying because we've actually got two different trigonometric functions going on. And we don't typically like that to happen. What we want to happen is that we've only got one trig function and then we're only dealing with one picture and one function to solve for. But if I look at what I've got sine thetas and cos thetas on each side. What I know about those two functions is that I can combine them to make tan theta, because the identity says that tan theta is sine theta over cos theta. So it looks like I can do some division on both sides. If I divide both sides by cos theta, then that will produce the tan theta that I need. So both sides like that. So the equation becomes much nicer. Sine over cos is tan. And the cos cancels out, so I'm just left with root 3. Okay, so that's a much nicer equation. It's only one trig function, and then I need to solve for theta. So I've got the same range of theta values, 0 to 360 as before. I've already got the tan graph drawn already in anticipation. So then with the calculator, I can start to get some values. So inverse tan, apply it to both sides. And from root 3, that's going to give me an angle of 60 degrees, which can go on the picture. And this time, this is a valid solution. This is in the right range of values for theta. All I need is all the other corresponding values on this chunk of the graph from 0 to 360. So it looks as if the only other solution is going to be somewhere over here on the next part of the graph, which I can get by adding 180 degrees. So that's going to be 240 degrees. And by the looks of it, those are the only two solutions that give me positive root 3. So those are my two solutions in that range. So I can add it to my solutions there. And that one's finished.